Welcome to Biology My Passion. I am Soumya Harikrishna. We are starting a new chapter in Class 9 Chemistry, Structure of the Atom. Atoms and molecules are the fundamental building blocks of matter around us. There are different types of matter around us. Why there is the difference? Because they are made up of different kinds of atoms. So, Dalton's theory came to the conclusion that atoms are the smallest and indivisible particle. But later experiments proved that even atoms are divisible. Now we know atoms can be divided into subatomic particles. The idea of these subatomic particles came from the study of static electricity. Static electricity is when we are rubbing substances, they get charge. From where this charge coming? It is from the atom. So that means atom has charge in it. When you are rubbing a comb on your dry hair and then you bring near small bits of paper, it will attract. Or you can use it with your scale also. When we were in school, we used to do that. Rub the scale with your hair and then bring near bits of paper, it attracts. The same way, if you are rubbing a glass rod with some silk cloth, the glass rod will get charged. When it is brought near an inflated balloon, the balloon will get attracted to it. So this is because of the static electricity. So these charges are coming from the atom. So the discovery of these subatomic particles were done by different scientists. J.J. Thomson, a scientist in the year 1900, he first discovered negatively charged particles in electrons by studying cathode rays. These electrons are negatively charged particle. So we write E minus representing the electrons. Their mass is negligible, and before that itself, E. Goldstein, another scientist, through his canal rays experiment in 1886 found another charged particle in atom called protons. Protons are positively charged, so we write P plus. Their mass is 200 times more than that of electron, so we consider mass of proton as 1 unit. So 1 unit is mass of proton, which is 2000 times more than that of electron. So electron has a very negligible mass, we don't consider it. Then later in 1932, another scientist called J. Chadwick, he discovered neutrons also in the atom. So the neutrons are the third particles which are neutral, or they do not have any charge. They are located in the center of the atom and their mass is also relatively equal to our proton. So we consider it as 1 unit. So proton has a mass of 1 unit, neutron has a mass of 1 unit, and electron does not have any mass because it is negligible. Electrons are negatively charged, protons are positively charged, and neutrons are no charge, or they are neutral. When these subatomic particles were discovered, it proved the Dalton's atomic theory wrong. Then the first model of structure of atom was proposed by Thomson. According to his model, he compared the structure of atom to that of a Christmas pudding. That is, Christmas pudding has a lot of currants in it, means or dry fruits in it. So if this is the base of that is a positively charged sphere, we can say, in that the black currents or the dry fruits we can consider as the electrons, negatively charged ones. Or the same way we can compare this to a watermelon structure. You know, watermelon has a fleshy pink color structure or reddish appearance. The whole reddish part can be considered as the positively charged structure. So it is a sphere of positive charge in which the seeds are studded. Those are like the electrons. So seeds are like electrons embedded in the positively charged sphere. This was the model proposed by J.J. Thomson. So J.J. Thomson made two propositions. One, atoms consist of positively charged sphere in which the negatively charged electrons are embedded. Second part, the positive and negative charges are equal in magnitude. As a result, as a whole, the atom is neutral. So the success of this was he could find that atoms were neutral in charge, but later experiments were done and they found out new things, but that could not match with his discovery, so this was discarded eventually. Followed by J.J. Thomson, Rutherford came out with his experiment. Ernest Rutherford, he did alpha particle scattering experiment. Alpha particle means it is a charged helium, that is two positive charges are there and the mass is 4 unit. For the experiment, he made a very thin metal sheet. He made it out of gold because gold is malleable. Malleable means we can make it into very thin sheets. So the sheet he made was only 1000 atoms thick, that means it's as thin as possible. Then he started bombarding this helium, that is alpha particles, positively charged particles, into the sheet. He expected these particles to be deflected by the subatomic particles. Alpha particles are very heavy, so he didn't expect them to get much deflected. Minor deflection only he expected. But his results were incredible. That is, most of the alpha particles passed through the gold foil without any deviation. Okay, so he was expecting every single alpha particle to get deflected, but most of them went without any deflection. That means they could pass through without getting hit on any of the subatomic particles. What does that mean? Lot of empty spaces are there in the atom or the gold foil. Then a few deflected through small angles and few large angles. That means some of them deflected through small angles and some of them deflected through large angles. That means when they hit on protons, they could deflect. And 1 out of 12,000 rebound. This was incredible because rebound means what? It is coming back. So a very few of them came back. He found that there is a central part of the atom which is very dense and heavy. As a result, the particles which hit that part could come back. So from this he understood there is a center of the atom where the charges are concentrated and it is heavy, or in mass it is the heaviest part. So there is a very good analogy given in your textbook. You tie your eyes and start bouncing soft balls on the wall. Each time you throw it on the wall, you will hear the hit sound and it comes back. But if it is a wired fence, lots of gaps are there and you are blindfolded. If you throw, you have only a few possibilities of them hitting the wire. Most of them will pass through the gap in between the wires. So this is also the same way. Most of them deflected, most of them went without deflection, means what? Lot of spaces are there, like wired fence, there are spaces in between the atom. And the most important conclusion was that there is a central part there for the atom. So from the above data, he also calculated that the nucleus of the atom could be 10 to the power of 5 times less than the size of the radius of the atom. So Rutherford, based on his experiments, put forward his theories. That is, 3 conclusions were derived. That is called the Rutherford's nuclear model, which states that atom has a positively charged center, that is called a nucleus, and most of the masses is actually occupying the nucleus. Then second part he told was atoms have electrons, negatively charged electrons, rotating around the atom in a definite orbits. And the size of the nucleus is very small compared to the size of the atoms. So if we think about the demerits or disadvantage of Rutherford's model of atom, according to this model, electrons are negatively charged particles. They are revolving in orbits, circular orbits around the nucleus. But according to electromagnetic physics, we know that if anything is traveling in circular orbit or circular path, it starts accelerating. So as the acceleration goes on increasing, they start losing energy. So as a result, finally they come to a stage where they lose all energy, they fall into the center. So as a result, the atom is not stable. Atom cannot exist like this because of this property. Due to this, the theory of Rutherford was also discarded. Since there were many objections to Rutherford model of atom, Niels Bohr came up with a suggestion or improving the model so that the anomalies are neutralized. That is, he told that atom has the nucleus and around that the electrons are passing. But instead of simply revolving around the atom in orbits, there are discrete orbits in which different electrons are moving. And these orbits are otherwise called shells, and these shells are very special. And when the electrons are passing through these shells, they do not radiate energy. They keep on rotating without losing their energy. So if this is the model proposed by him. Here is the central, this red dot is the central part of the atom, which is known as the nucleus. After that, 4 shells are shown or 4 orbits are shown. So we can have two ways of naming it. Either we can number it 1, 2, 3, 4. First shell, second shell, third shell or fourth shell. Or we can rename it as K, L, M and N. So K shell can have, K shell is the first shell, L shell is the second shell, M is the third shell and N is the fourth shell. Distribution of electrons in different orbits of the atom was described by Bohr and Bury, another scientist. They both proposed certain rules. They found that the number of atoms present in each orbit is a fixed number. To find out that, there is an equation they proposed, that is 2n square. N is the number of the shell. So first shell, if it is K shell, what will be the number? K into 1 square. So 2 is the maximum number of electrons that can come in K shell. Whereas L shell will be 2 into 2 square. So 8. M shell can have 2 into 3 square. 18. N shell can have 2 into 4 square. 32. But even though these can have 18, 32 and all, but outermost orbit can have a maximum of only 8 electrons. And an electron cannot fill the next shell until and unless the previous shell is completed, because each shell represents an energy level. So if you understood, please do me a favor, share with your friends. Please help me to make my videos reach to maximum people. Thank you so much for watching Biology My Passion.